This presentation is about the turning points of quadratics. So what is a turning point? A turning point is a point at which there is a local maximum or a local minimum. The local maximum looks like a peak and local minimum looks like a trough. For quadratics, there's always exactly one turning point. For other curves, you'll see there are more. And for quadratics, what will tell you whether it's a maximum or a minimum is the coefficient of x squared. That means the value of a, which multiplies x squared. So let's take an example here. Y equals 3x squared minus 2x plus 4. If you look, the coefficient of x squared is 3, and so that is positive, and so it is a U-shaped parabola which has a minimum point. If we now look at y equals minus 2x squared minus 2x plus 4, the coefficient of x squared is minus 2, and so being minus 2 less than 0, it is a n-shaped parabola, and so it has a maximum point. Example 3, we have y equals x squared minus 9x minus 8. The coefficient of x squared is 1, which is positive, and so it is a smiley or U-shaped parabola which has a minimum point. So to summarize, the coefficient of x squared, if that is greater than 0, tells you they have a U-shaped curve or smiley curve. If the coefficient of x squared, the a, is smaller than 0, then you have an n-shaped or frowny shaped parabola. By the way, if a is 0, then we don't have a quadratic at all, because then we just get y equals bx plus c, which is linear. So let's look at some more examples. Y equals x squared minus 8x plus 1. With that, the coefficient of x squared is 1, so we have a minimum point. It's U-shaped. For y equals minus 5x squared plus 2x minus 9, a is less than 0, it's minus 5, and so we have a maximum point. And for y equals 2x squared minus 5x plus 3, the coefficient of x squared is 2, that is positive, and so we have a minimum point. I hope that's clear. Okay, so how can we find the turning point of a quadratic? There are three major techniques, and really you should try and learn all of them if you can. The first is that if you have the quadratic in completed square form, that means you've written it as x plus something squared, and then multiplied by something possibly, and then plus something else. Then the turning point will always be, always occur, when the x plus q is 0, and the maximum minimum value will be the r. So for example, in y equals x plus 3 squared plus 1, the minimum point is obtained by solving x plus 3 equal to 0, which gives us x is minus 3, and the minimum value is plus 1. Let's think about why that is. If you think about x plus 3 squared, that is always going to be positive or 0. So the least that x plus 3 squared can be is 0, and therefore the least that x plus 3 squared plus 1 can be is 1. So the minimum value of x plus 3 squared plus 1 is 1. And when does that occur? That occurs when x plus 3 squared is 0. So that's when x plus 3 squared plus 1 is 1. So x plus 3 squared is 0 when x plus 3 is 0, which means that when x is minus 3. So the minimum point is minus 3, 1, means the minimum value is 1 of the whole output, and that occurs when x is minus 3. So this coordinate here gives us when the minimum point occurs, and this y coordinate gives us what the minimum value is. Similarly, for this next example, we have that minus 3 brackets 2x minus 1 squared plus 4 is our quadratic. So the value of x that makes the bracket 0 is 2x minus 1 equals 0, which means that x equals a half. So that's the x coordinate of the turning point. And then the turning point y value is 4. In this case, we get a maximum value because it's a U-shaped, no, not U-shaped, N-shaped. So it's a frowning, so it reaches a peak. And so the coordinates of that peak are 1/2, 4. So the maximum value is 4 and occurs when x is a half. If we take another example, y equals 2 brackets x minus 4 squared minus 3. Again, we see that the turning point occurs when the bracket is 0, so when x is 4, and the minimum in this case is minus 3. So do check through that you understand how that works. Okay, so you can also write a quadratic in a factorized form, for example, as written here. And in this case, the y-coordinate is 0 when x plus p is 0, or when x plus q is 0, and x plus p is 0 when x is minus p, and x plus q is 0 when x is minus q, which tells us that the graph in this case will cross the x-axis at minus p and minus q. And if we now work out the average of these two roots, the roots p and minus q, we now get the x-coordinate of the turning point. So let's look at some examples. If y is x plus 2, x minus 4, we can see that x plus 2 is 0 when x is minus 2, x minus 4 is 0 when x is 4, and the average of those two is x equal to 1. And if we substitute x equal to 1 into y equals x plus 2, x minus 4, we get 1 plus 2, 1 minus 4, producing the y-coordinate of minus 9. And so the minimum turning point is 1 minus 9. Similarly, if we have y equals x plus 1, x minus 2 times 4, we have that x plus 1 is 0 when x plus 1 is 0, which gives us the x-coordinate of minus 1. And similarly, x minus 2 is 0 when x equals 2. And then the average of 2 and minus 1 is a half, which tells us the x-coordinate of the turning point is a half, and the y-coordinate can be found by substituting a half into this formula. And last example here, we ask when is 2x plus 1 equal to 0? That's when x equals minus a half. When is x minus 2 equal to 0? When x equals 2. And the average of 2 and minus a half is 3/4. So the x-coordinate of the turning point is 3/4, and the y-coordinate is obtained by substituting 3/4 into this formula. Lastly, the turning point of a quadratic can be obtained from a quadratic when it's written in this form, polynomial form, and in that case the turning point is always has an x-coordinate of minus b over 2a, and the y-coordinate will be substituting minus b over 2a into the formula for the quadratic. And this also gives us the line of symmetry. So let's look at some examples. So if y equals x squared plus 4x plus 3, then a is 1, b is 4, and so minus b is minus 4, and 2a is 2 times 1, so we get minus 4 over 2, which is minus 2. So the x-coordinate of the turning point is minus 2, and if we substitute minus 2 into here, we get minus 2 squared plus 4 times minus 2 plus 3, which is minus 1. Similarly, if we have y equals minus x squared plus 2x minus 4, minus b is minus 2, and a is minus 1, so 2a is minus 2, and so you get minus 2 over minus 2, which is 1, and so the x-coordinate of the turning point is 1, and the y-coordinate is obtained by substituting that 1 into the formula. And last example, 2x squared plus 3x plus 1, b is 3, so minus b over 2a is minus 3 over 2 times 2, which is minus 3 over 4, and so the x-coordinate of the turning point is minus 3/4, and substituting minus 3/4 into here gives us the y value of minus 1/8, and so the turning point is minus 3/4 minus 1/8. And so as a summary, we can find the turning point of a quadratic by writing the quadratic in completed square form, in which case we get the turning point by getting the value, the y value as the r, and the x-coordinate as the value of x that makes the bit inside the bracket 0. If we're in factorized form, we can get the roots from solving x plus p is 0 and x plus q is 0, and then the x-coordinate of the turning point is the average of those two roots. And if we have just a polynomial form, the formula x equals minus b over 2a will give us the line of symmetry, and so the x-coordinate of the turning point.